What's up guys, welcome back to another video here at Chief Academy, and today I'll be going through repeated percentage change. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learn outcomes for today is to understand what repeated percentage changes are and how they relate to other areas of maths. It's also to solve repeated percentage change exam questions. So, what are repeated percentage changes? A repeated percentage change involves calculating the overall percentage change that has resulted from more than one consecutive percentage change. This can often be seen when we are dealing with money. In this lesson, we will focus on solving repeated percentage change exam questions and link it to other areas of maths. To go over the basics of repeated percentage changes, we need to know the basics of the percentage changes, whether it increases or decreases. As you'll probably know, if we times by 1.2, we have increased by 20%. But if we times by 0.8, we are decreasing by 20%. That can be seen in our examples here. So to say if I increased 100 by 20%, then by 20% again, I would have to do increase by 20%, which is 120, but then it'd increase 120 by 20%, which would end up getting to 144. You will already have seen the basics of using percentage change through compound interest, as there is some overlapping features. Remember, the number of times something happens is represented by putting the number to the power. So if I'm increasing 100 by 20%, say, and it happens over 5 years, I do 100 times 1.2 to the power of 5 to represent them 5 years. Once again, it's that time to have a go at some Math Genie exam questions. Have a go, pause the video, and unpause when you've done. So in our first question, a population of bacteria is increasing by 10% each hour. Find the percentage increase in the population every 3 hours. So 1.1 would be 10% increase of our original, because we have 100% to begin with, and we're increasing by 10. So we do 1.1 to the power of 3, because it's every 3 hours, we get 1.331. So we do 1.331 minus 1 to get it into a percentage form, because the percent's got to be lower than 1 for it to be less than 100%. If it was, say, 2.331 and you're minus 1, this would be over 100%, and that obviously can't happen. Then we times it by 100, and this will give a percent. So our percent would be 33.1. Now, in our second question, a shop decreases prices by 10% and then by a further 20%. Rachel says prices have now decreased by 30%. Is Rachel correct? You must show your working. So, if it decreases by 10%, we would times by 0.9, and if it decreases by 20%, we times by 0.8. So, if it decreases by 10% in the first time, and then 20% of that 10% decrease, we're doing 0.9 times 0.8. And this gives us 0.72. Now, if we do 1 minus 0.72, as it's less than 1, then we times by 100, we get 28. So Rachel is wrong, because the prices would have decreased by 28% and not 30. Now, with some repeated percentage change questions, you may be asked to find the percent increase which happens each year. This happens when you're given the total increase in percent and the number of years it happens in. Essentially, you're working backwards on them questions. We get told all the information to begin with, and then you work back to find the percentage increase per year. You may also be asked about other areas of maths which use repeated percent change. So it says lengths and volumes with cubes or shapes. So it's imperative you know your basics about lengths, areas, and volume. For example, when we were on about surface area a few videos ago, length cubed is your volume, and length squared is your area. So it's very important that you know the basics of that. Here are some more exam questions for you to have a go at. Have a go, pause the video, and then pause when you've done. So, in our first question, a population model assumes that the number of people living in Stoverton increases by X% each year. The population is expected to increase by 60% in 6 years. Work out the value of X and give your answer to one decimal place. So this will most likely be on a calculator paper, so make sure you have used a calculator to work this out. So, we have a placeholder value of Y, and in 6 years, which is why it has the power of 6, we've increased by a total of 60%, so 1.6. This would mean if we do the 6th root of 1.6, we'll find out what Y is, and Y gets us to 1.0814. This means X, our increase each year, would be our value of Y minus 1 times by 100. So our value of X is 8.1. Now in our second question, a car's value is increasing by X% each year. The car will have halved in value in 5 years. Work out the value of X. Give your answer to one decimal place again. Now, Y to the power of 5, because it's 5 years, will equal 0.5. This is because the value of the car will have halved. So if we do the 5th root of 0.5, we'll get our answer of Y, which is 0.87055. Now, as this is less than 1, we do X will equal 1 minus Y times 100, so our X value is 12.9%. Here are some of the hardest exam questions you'll probably be asked on repeated percentage changes. Have a go, pause the video, and unpause when you've done. So, in our first question, a cube's length is increased by 12%. Find the increase in the cube's volume. Give your answer to 3 significant figures. So, volume equals length cubed. As it is a cube, each length will be the same. So our volume is 1.12 cubed, as we've increased by 12%. This will give us a volume of 1.404928, and this is the percentage increase. Now, as it's bigger than 1, we do our value of V minus 1 times 100, and we'll get the increase in the cube's volume to be 40.5%. And this is the 3 significant figures. Now, with our second question, the cube's volume is increased by 25%. Find the increase in the cube's length and give your answer to 3 significant figures. Now, 1.25V, having increased by 25%, is going to equal X times our length, all cubed. Because X is our increase, and obviously length is our length. This would mean 1.25V will equal X cubed times L cubed. This is the biggest mistake people make because they don't cube the X and the L independently. Now, as we know, L cubed simply equals V because it's a cube, meaning we can cross cancel our V and our L, meaning 1.25 will equal X cubed. Cube root 1.25 and X equals 1.077217, carrying on. Now if we do our value of X minus 1, as it's greater than 1, times it by 100, we'll find the increase in the cube's length to be 7.72% to 3 significant figures. And that, ladies and gentlemen, is the end of today's lesson. As I did say, it was that easy. Thank you very much for watching. Please like, subscribe if you haven't already, and I'll see you in the next one. Goodbye.